Hi, Hector. So to help you with this problem, there's just a couple things you need to do to approach it, because you said you're a little confused on how to approach this stoichiometry problem. So basically, the first step is that you're given the weights of different compounds, which are the reactants in your given equation. And now, to figure out what the limiting reagent is, you have to first convert the weights of your different reactants to figure out the number of moles of each reactant that you have, because each of your reactants weigh different amount per molecule. Therefore, so you can't just compare the weights as they are, because 55 grams of one compound is not necessarily more of the compound, more number of molecules of the compound than 25 grams of phosphorus. So in order to know how many molecules you have rather than a weight, you have to first convert to moles. So to do that, you have to look up on the periodic table what the weight of your different elements are that are in your reactants. So in this case, we have chlorine, which weighs 35.45, and phosphorus, which weighs 31. So the first step would be to calculate how many moles of Cl2 are there in 55 grams. So to do that, we just take the weight of chlorine, which is 35.45, and we multiply that by 2 to get our weight. And if we do that, we find that the weight of one molecule of, the weight of 1 mole of Cl2 is 70.9 grams. So Cl2 is 1 mole of Cl2 is equal to 70.9 grams. Now we're going to do the same thing for phosphorus. So the reactant involving phosphorus is P4. So there's 4 phosphorus atoms in each molecule. So now we're going to do a similar thing. So we're going to take the weight of phosphorus, 1 atom of phosphorus, and we're going to multiply it by 4 because there are 4 atoms of phosphorus in the molecule P4. So it's just 31 times 4. And if we do that, we get 31 times 4 is 124. So P4 is equal to 124 grams. So now we know how much 1 mole of P4 weighs and how much 1 mole of Cl2 weighs. And remember, a mole is an amount of something. It's like saying like a dozen. A mole is just a number of something. So 1 mole of P4 weighs 124 grams and 1 mole of Cl2 weighs 70.9 grams. So now, using that, we can now figure out how much of a mole, like how many molecules we have of Cl2 and how many molecules we have of P4, and then using that, we could then figure out what the limiting reagent is. So to figure out how much of Cl2 we have, we have 55 grams, and we know that 1 mole weighs 70.9. So we're going to take 55 over 70.9 to figure out the number of moles of Cl2 that we have. And if we do that, we get 0.78 moles. Again, that's the number of Cl2 molecules that we have. We have 0.78 moles of Cl2 molecules. Now, if we do the same thing for P4, we take 25 divided by 124. Let's just write this down. 0.78 moles of Cl2. And then we have 25 over 124, which is equal to 0.2 moles of P4. Right, that should be Cl2. Okay, so now we know the numbers of each thing that we have. We know the numbers of Cl2 we have and the number of P4. So now we can take that and put it into our equation and see which one is the limiting reagent. So let's start with 0.2 moles of P4, and let's let's use that as our starting point to figure out how much of everything else we would have in our equation if we were starting with 0.2 moles of P4. So we have, in our original equation, we have one molecule of P4 with 6 Cl2 gets you to 4. So now if we're starting with 0.2 P4, we would get 0.2 P4 plus, so here it's 1 to 6, right? So there's 6 Cl2 for every 1 P4. So it's going to be the same thing. 6 times 0.2 is 1.2. So if we start with 0.2 P4, we're going to have 1.2 Cl2. And then we would have 4 PCl3, and in this case, so 4 to 1. 4 to 1 is 0.2 is to 8, so 0.8 PCl3. Now we already see how much do we have. We started with 0.78 moles of Cl2, and if we're starting with 0.2 moles of P4, we would need 1.2 moles of Cl2, and that's not enough. So therefore, we're going to do it with the other way. So we're going to start with 0.78 moles Cl2. And now we're going to divide that by 6 to get the amount of P4. 0.78 divided by 6 is 0.13. And that would get you to 0.52. If we take 0.13 and multiply it by 4, because 1 P4 for every 4 PCl3, so 0.13 times 4 is 0.8 PCl3. Okay, so now we can figure out how many grams of PCl3 by doing the reverse. So we can just do 0.8 moles of PCl3 is how many grams. So we would just take the weight of PCl3. We know 1 P is 31. Cl is 35.45 for each of them. So 35.45 times 3 is equal to 106.35 plus 31 gets us to 137.35. So 137.35 grams per mole. So if you had 1 mole, you would have 137.35 grams. We don't have 1 mole. We only have 0.8. So we're going to take 0.8 times 137.35. And that gets us to our final answer of 109.88. So we would have 109.88 grams of PCl3 being produced. And that would be our answer. All right, I hope that was helpful.